one of the challenges biodiversity informatics faces is not so much getting data online, but how we're actually going to analyze that data. We have lots of web pages, for example, for DNA sequences, for specimens, and for publications. But the trick is, how do we bring all that information together without having to click through different websites and cut and paste data? In other words, how do we achieve something like this, where all these different sources of information are linked together, such that we could go to GenBank, and then we could link from that to, for example, specimen data, to information on taxonomic names, to publications, and so on. One way to do this is using linked data, and I just want to give you a quick demonstration of some of the possibilities. The idea behind linked data is that if we have nice resolvable identifiers for the things that we care about, and that these identifiers can return data in a form called RDF, then it becomes quite easy to link all these things together. So for example, here's a DNA sequence. I'm going to go and retrieve some information about that DNA sequence. To make it more interesting, I'm going to throw in another one as well. And what this linked data browser is doing is it's collecting information about those two sequences. You can see this information in a fairly hideous looking grid view. Here are all the facts that we know about those sequences in terms of when they were created and modified, other kinds of links which we're going to explore in a moment, and some very basic statements about what those sequences are. We can learn a little bit more about these sequences if we can view their relationships, and we're just going to do this using a little graph view. So this linked data browser can show you a graph of the things that we have. And what we have are sequences. This is one of them. Here's the other one. And they're connected by a number of things. For example, up here we can see this is an object. This is the ant taxon and NCBI taxonomy. These are two ant sequences. Down here we have the specimen that both these sequences happen to be derived from. We can add this information just by simply clicking on this link and saying we'd like to get the specimen. So now we have, there's the ant specimen with the information that it has about these sequences. And let's just try and clean this up a little bit. So here's one of these sequences. It is connected to the specimen that it comes from. It's also connected to a publication, and it's connected to the taxon it comes from. We can add the taxon just by clicking on this link. Now our graph is starting to get a little bit messier. And we'll also have a look at this one, which is the publication. Let's go and add that. Now our graph is going to get quite a bit messier because this particular publication is linked to a whole lot of other information, including lots and lots of sequences. Let's switch views now and go to the Navigator view. And what you're seeing here at the top, we have the things that we've loaded in. We've loaded two DNA sequences, some information on a specimen, a taxon, in this case the ant these sequences come from, and the publication that published these sequences. The Navigator view lists these objects, and we can investigate them in a little bit more detail. For example, this is the article that published those sequences, and you can see it's linked to a whole lot of other sequences. It's linked to various papers that cite that paper. And down the bottom of this view, down here, you can see the two sequences that we've added to the database. So there's a link between these sequences and that paper. Of course, articles don't exist in isolation. They are parts of journals, and this is a link to the journal up here. If we click on that, we can go and get some information about the journal. And for example, we discover this journal is PNAS, and that's what the journal looks like. So what we can do is, by grabbing information in this consistent way, essentially taking these identifiers and getting some RDF, and if all these different identifiers resolve to things which use the same identifiers over and over again, then we can link the things together. So we can get graphs like this, which link specimens, sequences, publications, and taxa. And then we can extract some more information from this. For example, if we want to see where in the world this data comes from, we just have to click on a map, and this fairly crude Yahoo map will eventually tell us that the specimen comes from Australia. So based on that information But the ant specimen, we can locate where the sequences come from geographically, which also tells us where the paper, what part of the world the paper was studying. We can also extract some other information. For example, we have information on a timeline, and in this case, what we're seeing here is information about when these sequences and the taxon record were deposited in GenBank. So what we've managed to do is take a few sequences, 2 sequences, discover the specimen these sequences came from, discover the taxon, link that to the paper, and put that paper in the context of the journal. This is a very small example, but you can imagine that just by adding more sequences and more specimens, eventually we can build this linked web of data. So all we need, in effect, is to have consistent identifiers that resolve in this way, and then a vision something like this would be quite achievable.